Good morning. Can you all hear me? I'm very happy and very proud to be here this morning. I'm very grateful to this opportunity, which brought me back to the school that I love, where I started. I still remember the day when I walked from that door, same hall 40 years ago, to take a course which they called at that time music appreciation. I did not know the relationship. Music appreciation, engineering, let me try. Only later on in life, when I grew up and started to work and appreciate things, I found the relationship between music and engineering. And there is a relationship. Thank you. He was an American gentleman. I forgot his name. You know, he was a very sweet guy, a musician. I cannot tell you his name anymore. Maybe. If I tell you his name, he taught you at the same time. It was here. I used to sit in the back. You know, it's my favorite place was in the back. Easy to get in and out. Anyway, my title is a little bit provocative, you know, but it's not really what you see. You know, I just want to talk. I don't want to talk about mechanical engineering, electrical engineering. I want to talk about evolution. Evolution of a human being, of an engineer, of a product, of a company, of a technology. This is the title. This is where the focus is going to be this morning. But before I take you there, I have a couple of slides, which I'll share with you. This is my name. Professor Shaban has done a good job introducing me. I will not spend a lot of time on that, but I am a global sales manager responsible for a few products, because ABB manufacture hundreds of thousands of products. I'm just responsible for a set of these products on a global basis. Anyway, again, a couple of slides. ABB, for those who do not know, we are about 150,000 employees, $35 billion in revenues. It's a publicly traded company with headquarters in Switzerland. ABB, just like anything, take the AUB, you know, AUB, you have different schools, you know, again, ABB has different business divisions, you know, from the low voltage to the power system, power products, robotics. This is what we call discrete motion, motors and robotics. I am in this one. I am in the process automation. This is my domain, process automation. To automate plants, production plants, factories. This is the typical. This is what I have done for the last 30, 35 years. I started down in the construction side, building the plant, but from an electrical point of view, from an instrumentation point of view, from a control point of view, from an automation point of view. I was not in charge of the mechanical construction of piping and vessels and all of these things, but you learn. You learn as you go on. This is a key point. I want you to listen to the word learn. Never stop to learn. Whether you are 20, 30, 40, 50, regardless of your age, learn. Learn from others. Learn as you go along and evolve. This is a team, evolution. So, this is the plant. I spent many, many years building things like that. Power plants. This is a typical refinery, by the way. A desalination plant. But then I concentrated on the upper part, the control room. But this is what you see, a picture. This is where the operators are standing. But behind this picture, there is a whole infrastructure. How we read, how we sense, how we actuate, how we drive, how we move, how we interlock, how we control, how we do all of these things to we have a production plant which is running smoothly, which is running automatically, or as far, you know, there's nothing which is 100% automatic. There's always going to be operators. But instead of having an army of operators, you reduce the number of operators. And we have to be careful how to present that. You know, in some countries where they have an oversupply of manpower, where they have people, a lot of people, and it is cheap to hire people than buying machine, then you have to present it in a different way. From a safety aspect, maybe. You know, it contributes to the safety of the plant. So you always have to think about your target audience. where they are coming from, what they do, and then target your message in order to suit the purpose. Always in an honest, straightforward way, but give them the message, maybe not the one necessarily that they want to hear, but the one which really suits the purpose, their purpose. So, let me show you a little bit more about the control plant, the control side. This is a typical control arrangement. There are many control components here. Have you heard of the term distributed control system? Programmable logic controllers? All of these things are components. But then we have some devoted controls for safety purposes, where the speed is key. Speed to trip something, to stop something, to close something, to open something, to prevent a certain problem from occurring. Safety. Then we have things related to production management. Take a typical pharmaceutical company. You know, the way they do controls is different from the way we control a refinery. We do what we call a batch control there. And we always have to interface to the upper levels, because this is, you have the field level where you have your sensors and your actuators and your drivers and your motors. Then from this level, you go to the control levels where you have the logic, where you have the controls, how you want things to control, to operate, to open, to close, to prevent, to interlock, as I said before. Then you go to the operator level where the operators can see things. He can put them on automatic, semi-automatic, manual. He can do things to change. And then from there, we can go to upper level to send this information from the production level to the management level. This is what we call information management system, which is a layer on top of that. Then we have some more layers when it comes to the optimization, when it comes to things, new things like energy efficiency and advanced process control. I'm throwing a lot of words on you. I can spend a day talking about each and every one of these subjects. I just want you to have a flavor of what's involved under automation, under the automation umbrella, under process automation, automating a plant and how we do that. So it's a big interconnected thing. We have interfaces. The electrical, I said, you know what, I'm talking about automation, but again, the electrical is an integral part of the plant. We interface to the MCC, to the motor control system center. Have you heard about this term, motor control systems? Okay, high voltage, low voltage is clear. But we have motor control systems which have become recently smart. Smart motor control system? Smart, yes. This word smart is not only applicable to your phone. Actually, a smartphone, we started using the term smart when it comes to sensors and transmitters 20 and 25 years ago. Smart product. It means a product that can give you a lot more information about what's happening in it from an industrial point of view, so that you can do easier maintenance on the product, so that you can integrate it, so you can have a maintenance schedule run for it. So smart, and we interface to all of these components in the plant, forming a whole picture of control. Because the motor control system is the way we drive things. We actuate, we open, we push the flow. Or if you have gases, compressors. So this is where we are. This is a small pictures of what we do in a typical process control environment. Just to take you a little bit deeper, not too much deeper, this is a typical topography of a interconnection. So we have a network, we have controllers, we have sensors, we have safety related, we have substations, we have everything which are interconnected. All of these elements in a typical industrial plant. Some of these elements might not be there, like a substation automation, for example. Or some of them, they do not necessarily need a safety system. So what is the difference between a typical control system and a typical safety system? Speed of action, number one. Approvals. It takes us years before a certain safety system has been certified by authorities, special authority to certify a safety system. And the use of safety system has increased tremendously over the past 20 years. some applications in the past that we used to include it under the umbrella of a normal control system, now they need these devoted controllers, they devoted safety element in it. So this, I don't want to go too deep, but this is to give you an information. Yes, we have networks. Yes, we have servers. Yes, we have integrated and embraced a lot of third-party software and hardware in the creation of this control system. In the past, many of these, ABB is included, we used to create everything from scratch. It was so expensive to have a control system for a plant. Now it's a lot cheaper because we are integrating things. But you still have to do your homework. You still have to do the work in order to cement everything together and make it safe to be used on a control plant. That Microsoft operating system must be used, adapted in a way. So this is basically what I do, these type of topologies. But what has helped me a little bit is that I started from the site. I started from construction. I started working with these rather than just sitting behind a desk making proposals. You have to go out and you have to touch things. I have a son, he's 26 years old. He said, I want to be an electrical engineer. I said, fine, you go together. And then he got his first job offer. He got a couple of offers. And then he told me one of them is he will be a trader to trade oil, with an oil company. And the second one is to be a field engineer. I told him there is no hesitation. You have to be a field engineer. Forget about sitting. You are still too young to sit behind a desk and just fill out orders or trade or do the business side. The business side will come automatically at a later stage in life. So let us move now a little bit. This is what I call the value chain. This is what I have done many of these things. I was in construction, I did engineering, commissioning, programming, but this is the value chain of a typical automation project. And you have to interface, as I said, to upper values, to upper systems, to upper level systems, in order to send information to decision makers, in order to tell the procurement department, listen, procurement department, I am in need of this raw material or that raw material if you are in a pharmaceutical company, for example. But one thing which has gained a lot of momentum and attention recently is this last item that was added, and it is protection. To protect your installation. Protect it from a safety point of view, but more importantly these days, from a cybersecurity point of view. Cybersecurity and cybersecurity planning now is embedded in the early stages of design. Whenever we are designing a control system, whenever we are designing a plant, we say, okay, let us embed in our design cybersecurity measures so that we have defenses. Because what happened just recently, big insurance company like Lloyd's, if you don't have a proper cybersecurity measures in your production plan, they will not insure you, or your insurance premium will double. Because they have heard and they know what's happening with cybersecurity. Just maybe you have heard about a company called Target in the United States. 50 million accounts were stolen. So there is no 100% protection when it comes to cybersecurity. And now cybersecurity is not limited to your personal computer at home. No, it is now the target is industrial plants. And that's why we have decided to put cybersecurity and give it a lot of focus when it comes to computer-based controls. So this is what we do, computer-based controls which have elements from different leading software and hardware manufacturers, plus our own software and hardware in order to cement everything together. So this is the industrial chain. Let me go to the evolution story. I have evolved. I have changed over the years. I was a very raw, maybe naive, when I walked from that door 40 years ago. I didn't know. So my first evolution happened when I joined ABB. 4 years of evolution. I did not graduate as a perfect engineer or a perfect human being, but it was my first major evolution. I learned. I respect the knowledge of others, the knowledge of my professors. I also respect the hard work of some of my fellow classmates. I evolved. I became a better person, a better engineer, better prepared to meet the real world out there. But I was not in any way ready to contribute effectively from the first day of my work to my employer. That's why a second evolution came with my first job. I came from a home where my mother she used to be the manager. She managed the house. I went to a company. She told me, Malek, welcome. This is your office, and you have 300 people from 10 different countries working for you. I had to manage 300 people. I had no idea how to manage anything in my life. Everything was managed for me, was prepared for me. So I had to evolve, to assume this responsibility of managing people, which is not easy, and at the same time of learning. I turned down a very good offer to work in a big production plant here. They make refrigerators and washing machine not too far from Khaldi Shwefet. I don't remember. I think they gave me a very generous offer. You are going to be here next to your parents, next to your friends. Good offer, we'll give you a car. But I said no, because I realized that I can learn everything that they have to offer me within a month or two. And then what? No, I said no, I will go. And this is what I did. I went to Saudi Arabia and I was immersed in work. So you have to say no, regardless of your emotion and passion and your attachment to other people, because it's your future. And you have to turn down some offers which are not going to give you any real development or evolution opportunities. My next evolution step came really when I joined ABB. It was a different world. I went from Saudi Arabia to Germany. So I had to evolve. I had to work on many things in order to evolve and move on. So evolution of a person, continuous evolution. We all have to continuously evolve. So evolution of people is very important. But at the same time, there is also an ongoing evolution of a product. Look, just take a simple phone. It used to be one single purpose, fixed line phone. Now you have like a mini computer in your pocket, online every time, reachable every time. Products evolve. Not only human beings evolve, but products evolve. Look at the cars. I was riding with a friend of mine. He just bought a BMW. This car is full of electronics and sensors. It drives itself. He doesn't have to push any pedal. It slows down when it sees that he is getting close to other cars. But again, the people who are in charge of servicing such cars, they also have to evolve in order for them to be able to maintain these cars. So the products are evolving. The product that we use, a car, a phone, are evolving. We have to evolve. So not only a human being or the person or an engineer has to evolve, but there is a product evolution going on. Besides the product evolution, we have companies evolving. Who remembers? I mean, you are too young to remember. You were not even born when Apple II came into. You are young at heart, Professor. Apple II, just a little bit less than 40 years ago. But now Apple is the most valuable company in the whole world when it comes to market capitalization. It is. It's more valuable than ExxonMobil or General Motors or IBM, all of these big names that you have heard about or heard of at one point or another. Apple has evolved. Look at Google. From a search engine startup to a mammoth technology company. Really. Their hands and fingers everywhere. They keep buying things. They are evolving from a search, we all know it, they are a search engine. This is how I use it. But now their products are in your phone. Their products will be on your wrist. Or when you wear glasses, it's coming, the next product. They are evolving. The business is evolving. The market capitalization is evolving. Evolution of a company. But there's also evolution of technology. Look how the computer has evolved over the years. Look how information technology has evolved over the years. Look how communication has evolved over the years. And now we talk about disruptive technology. Anybody has heard of this term? Disruptive technology? This is a very prestigious type of an innovation. MIT they publish every year a list of disruptive, the term is a little bit confusing. Disruptive? Is it destruction? No, disruptive. Why we call it disruptive? Because they disrupt a certain established product and they replace it by another product. Your smartphone has disrupted the personal computer because your smartphone is the computer now. Maybe some of you can still know a company called Kodak. Kodak used to be one of the most respected companies. I visited their headquarters in Rochester, New York many times, went to their museum. It never occurred to me that Kodak will disappear or will just go out. But this is what happened. Because digital photography has disrupted and displaced chemical-based photography. They were a chemical company before they became a photography company. So what is a disruptive technology? Disruptive technology is a technology which appear on the field and they change the dynamics of the market. They displace product, they create new value, they create new markets. And if you are lucky enough to have your name, the name of your company published on the MIT list of disruptive technology, this is very prestigious. And believe it or not, you can make a lot of marketing stuff out of that. This is what ABB did last year. ABB has perfected what we call the DC circuit breaker. They have perfected it in such a way that it can now be used effectively when it comes to renewable energy and distribution of renewable energy. There was always a problem with that. So this is a disruptive type of technology, but it is in a positive way. Negative way for those companies who have been displaced, maybe. But it's positive for our civilization, for our human being. It's good to have new things coming. So they publish a list of up to 50 disruptive technologies every year. Keep an eye. Check them. They are published on a regular basis. There is no secret that we live in an interconnected world, interconnected economy. Globalization is a big term here. The way we have used social media for commercial purposes, for social purposes. The economy of the whole world is so interconnected that it is very difficult to isolate a problem sometime. In 2008, if you remember, there was a big financial crisis. It started with a bank in the United States, and then it affected the whole world. This is how the economy of the world is interconnected. So we are living in a different type of an environment where we have an interconnected economy, and we have evolving products, evolving companies, evolving technology, and all of these combined will make it necessary for you as an engineer to continue to evolve with time, over time. But you are also expected to contribute all the time. Contribution. MIST. MIST, anybody knows German here? Okay, forget about German. Let's concentrate on MIST as an English word. MIST means a fog, a light fog. Sometimes it hinders your vision a little bit. This is how life is sometimes. At your work, at your home, whatever. But sometimes everything is running smooth. All of a sudden you have a mist. It hinders your vision. But you don't have to give up. You have to make something, to do something, in order to lift up the mist so that your vision is clear as an engineer, as a person, as a company. And the way to lift up the mist is in the word itself. You have to motivate. If you are a leader, you have to motivate your troops. You have to motivate your faculty members. You have to motivate your students. You have to innovate. You have to do things a little bit differently than what you have done before. Not necessarily by creating something new, but by innovating, by doing it a little bit different. This is very important. You have to steer. Don't always be steered. You have to steer things. If you find yourself in a situation, I have a block, I cannot see, I don't know what, try to steer out of it. And you have to be trained. Continuous training is really a very good thing. We do it all the time. We always try to motivate, innovate, support, steer, and train our people so that we are always evolving to the better. We have to evolve. Missed. So, if I have the privilege to share with you some thoughts, just a couple, because if I make the list too big, nobody will remember anything. Just a couple of bullets, couple of thoughts. I always like the idea of working in a company or for a company as if I own the company. This has always been my motto. This is how I have to believe in what I'm doing. Suppose that guy who is selling the BMW, but he does not drive a BMW. He's driving a Mercedes or something. It means that he does not, it does not look good. Because it means that he does not believe in the product that he is trying to convince you to have. So you have to believe. You have to believe. And you have to work as if you own the company. Another thing is that you have to work on yourself. You have always to learn. And there are always tons and tons of things to learn. Knowledge base, doing things differently, learning something, going to training. These are very important things and make a difference. I had the privilege to turn down few positions, good positions, because I said, I'm not going to be able to make a difference. I'm not going to be missed if I'm not there. I like to be missed if I'm not in the office. No, where's Malek? He's not there. We are missing somebody. I like to make a difference. I hope that you do too. Try to make a difference wherever you are. Make a difference by being able to contribute, not by standing by and being just neutral and let others decide for you. You have to make a difference on your own. And you have to take calculated risk in life. I turned down that easy, nice job, 5 kilometers away from my house, away from, just nearby my friends. Why? And it was a risk. I tell you, it was a risk going to a different country 40 years ago. It was not so easy. But I did it because I was convinced. We have to take some calculated risk in life. And you have to make a difference in whatever you do. Make a difference in whatever you do. I want to share with you a short poem, because we Lebanese like poetry. I don't know. But a short poem, I said, we can read it all. It says 35 engineering. I have been 35 years in business. 35 years of engineering. What are the results? A lot of stress, gray hair, and sleepless nights. 35 years of engineering. What did I learn? I learned to listen, to do, and not to complain. You cannot sit down and complain. My gosh, go and do something. Go and do it. Listen. You have to listen to the others who have been there or who are superior than you are. 35 years of engineering, what did I gain? I gained a lot of pride, a lot of joy, and the desire to do it all over again. I'm ready to do it all over again. Absolutely. 35 years of engineering. 35 years of engineering, what do I advise? I want you to be smart, work hard, and think wise. Thank you all for your attention today.
هنسميك مالك المتنبي بعد شوي.
Thank you, thank you.
Okay, thank you. That was really, really interesting. I'd like to open the floor. Yani, we don't have too much time, but never mind. Let's have some feedback from the audience, from the students. Now we have a class coming in. Maybe you have to repeat your lecture.
I'm ready to do that. I'm ready to do that.
All over again, yes.
Thank you very much. Thank you very much, Professor. Thank you, sir. Thank you.
Okay.
You want me to repeat? I will repeat, Farid.
We'll have some discussion. Dean Hajj will start.
I'm stationed in Mannheim, Germany.
طيب.
This is the crowd that I like to see.
Dr. Hajj, you have a question?
Sorry? Thank you very much, sir. Thank you. Thank you.
Ahmad, please. Malek.
Yes, please.
Many of our students end up in consulting, end up on the business side too early. And from what I understood from what I heard you saying, it seems you're advising against that.
I'm not, yeah, okay, please.
I'd like to get your feedback, since there's a lot of our students here, a lot of them graduating, making decisions on offers now.
Very good question. Very good question. If you are a young engineer and starting engineer, I can advise you not to think about sitting behind a desk and doing the business stuff. Okay, if your father owns a company or your mother is the chairman of a board, it's a different story. But if you are a young engineer who is trying to establish himself and herself as an independent, contributing individual in this society, I recommend to you to work, to touch things, to do things, to install, to touch, to commission, to start up. You have to see things the way they are. When I started working in Saudi Arabia, in charge of these 300 people, I've never managed any people, the foreman used to laugh at me behind my back. Well, he doesn't even know what a contactor is or a relay is. I didn't see a contactor here. I didn't know how we can do interlocks. I did not. I learned a lot of theory. This is true. But you start to contribute when you go beyond the theory, when you go to the real life, and we start doing things, touching things. You spend 23 years before you graduated, 23 of your lives maybe doing homework, typing your papers, doing everything from behind the desk, listening to people like me talking and doing PowerPoints, going from time to time to a lab, fine, but you are not yet ready to contribute when you graduate. This is the reality. You are not. You have to be trained. You have to be taught the real life aspects. That's why I recommend that you wait until you know when somebody, so that no foreman or anybody will laugh behind your back because they know a little bit better. Of course, they have been 20, 30 years doing something that you are not, that you haven't seen, you don't know about. So I had to do my homework. I took some books, some catalogs home at night, and I studied. I went and I looked. I touched. I said, no, I want to do that. You know what I mean? You have to do practical things. And once you do that, then the time will come when you can move to the business side of the operation. Now I am in the business side. But I spent 10, 15 years on the practical side, on sites, doing construction, doing commissioning, doing designs, talking to suppliers and vendors and arguing and going down and having workers around me and foremen and junior engineers. And then I have done that enough. I know what's involved in real life. I know when somebody say PLC, what does this mean? How is programmed? What are the problems? When somebody says DCS, what does it mean? Okay, I know these things. That's why I move now to the business side. I'm the in sales and marketing on a global level. So don't push it. Learn. I'm still learning. Please, doctor. Thank you very much.
But sometimes I advise my students to be practical. These days are difficult days. And so a student comes to me to the office. I advise them usually to select the best of the two. Sometimes none of the two job offers that he got is actually in the field where he can touch things. Yet he will be still able to develop, even if he goes on a consulting job initially.
Yeah.
Because even consulting job, there's a lot to learn there.
Sure.
There's a lot of things to really learn, integrating things, and understanding the business is going here and going there. So there's still an opportunity. I just wanted to just like to clarify this.
No, it's
nuance there.
very valid point. Of course, if you stay home after you graduate, there is zero evolution. There is zero improvement. So you have to take what's available, but don't settle down. If you don't see that, remember the mist I told you about, for those who are not, mist, sometimes this is a misty situation. You have to work in order to lift the mist. So you have to take what you get, what you have, and work in order to, if you are not satisfied. You know what Picasso said one time? If you do not, Picasso, you know, the paint, he said, if you do not believe in what you are doing, if you do not have an action plan, you will never be successful. So you have to have a plan in life. And not any plan on paper, but a plan that you believe in. This is my plan. A plan that you believe in. A plan that you will act on. You have to act. A plan, believing in this plan, acting on this plan, will lead you eventually to success. Absolutely. Absolutely. And evolution, as I said, not working is zero evolution, and this is the worst possible option. Take what you get, work on it, but do not be satisfied until you believe in what you are doing. Believing. And if you don't feel yourself that you are making a difference in what you are doing, it's a satisfying job. I tell you that. I know that Lebanon's conditions are a little bit, but you know, you are the best of the best. You are the best of the best. And don't let anybody else tell you anything different than that. Not only in this school or in this university, probably in this country and in this region. You are the best of the best. And this is my starting point. Please.
It's okay, probably we're running behind time. I can answer you.
Please.
We're seeing an increasing number of students trying to establish their own companies right after graduation from here. And we've had several presenters, who are graduates and who have gone through this experience, and they presented to our seniors,
Yes.
what they're going through.
Mm-hmm.
And they gave very motivated talks about it.
Possible.
What they're going through the things.
Yes.
Taking care of.
I don't believe that somebody who has established a company will come here, stand in front of you, and give you anything but positive review. I don't believe that he will come here and say, "Oh, don't do it." You know, he is in it, therefore it must be good for him. But I'm saying this is not the norm. It's not the norm that you graduate unless your father is already in business, and he say, "Okay, my son, I have a big company, I'm establishing a new division," but you know, he has resources, he has support. But if you are like I was at one time, an individual working hard to establish himself, I was the first in my family to join the AUB, you know, it's different, you know, it's different. No, making your own company is not the right way. You have to learn from people like Professor Shaban. You have to learn from people who are a little bit older. Maybe people like me. Maybe people like the professors and the doctors, your doctors here. Maybe people who have been in that business for a longer period of time. You can learn from them. And don't be shy at all to learn. Go with the mentality and with the attitude that you want to learn, that you want to evolve. This is our theme, evolution of an engineer, of a product, of a company, of technology. Any other questions? I would be happy to respond. I will be here at least till lunchtime. I would be happy to talk to you on an individual basis or give you my email. My email was on the presentation here.
It will be available in the department
Yeah.
if you want all the affiliations.
Or you can watch the video again. Thank you very much again.
Okay,
Thank you.